hello everyone, and thank you for joining us for the third and final session of Lena Nyström's mini-series. If you haven't watched the first or second session yet, stop it right there, go to our website, watch them before continuing with this part. Lena, after two of these, I think it's safe to say everyone here already knows who you are, so I'm skipping the formal intro and I'm leaving it to you. But I do want to take this opportunity to thank you for your valuable thoughts here and for sharing them with our testing community. So thank you very much. You're the first ever to lead our mini-series, so it's a great honor for us.
Thank you for having me, and awesome to be the first.
So as you already know, Lena, I'm sure you already know PractiTest too, so just a swift intro to our product. PractiTest is an end-to-end test management platform where you can centralize all your QA work, processes, teams, and tools to enable one source of truth across your organization. With PractiTest, you can make informed data decisions based on end-to-end visibility provided by customizable reports, real-time dashboards, and dynamic filter views. We help our users to align testing operation with business goals and deliver better products faster. We are proud to be trusted by these great brands and hope to keep deliver the best test management solution for them and many others. You can check out our next live demo session, sign up through the QR code or the link below, see us in action. And our next webinar after Lena's is Joel's, our very own, is our Chief Solution Architect and co-founder. You can check out his webinar to find out how you can improve your test management processes. So, Lena, I think the stage is yours. Take it from here.
Awesome. I know last time I noticed Roblox as your client, and now I saw Wendy's. So I really wish I had a Wendy's joke somewhere in my presentation. If you have joined us before, you notice I have a slightly different angle to my video today. I'm sitting down today. I usually stand up because I really need to pace myself today, because when you start doing a 3-piece series, you think, how am I going to fill all of that space? And then you end up trying to cram everything you didn't get to say in the first two into the third one. So let's see. Thank you for being here today, again, letting me talk about how we can make sense of the things our software is saying. We have done an overview, perspectives. We've looked into different stacks. Today, we're going to go deep dive. We're going to go nitty gritty. There's going to be a lot of extremely specific examples to give you some ideas of how you can use these clues to explore. Very quickly about me, because I don't know if there's someone in this part that hasn't joined the other two. I've been doing this since 1999. I've been a developer for about a decade. I've been doing a ton of different roles in testing, mainly in how can we improve, how can we do things better, how can we learn. And since 2017, I am focusing on people and organizations as a manager. And also, I've been blessed to do public speaking like this since 2017. I am currently engineering manager at Nordnet, a pan-Nordic digital platform for savings and investments. Super fancy. As I mentioned, we've gone through part one, where I did an introduction. I talked a bit about different perspectives like security, accessibility, usability, and tried to explain why this is actually not so easy. In part two, we looked into how the characteristics of the different part of the stacks could give you an idea of where the message is originating from and what to do about it. And today we're gonna look more in detail about how to find these clues and how to use them to uncover risk. Because that's my main message for today. And if you take away nothing else, please take away this. There are clues in these messages and we can use them to uncover risk. We just need to learn a bit. So if you remember this picture from the last time, this is an example of what email validation could look like on the front end, the back end, the database, and the mail server in this case. And I want to really implore you not to trust any of these layers. You need a combination of them to be safe, to keep our data and our application safe. So don't trust the surface. I also mentioned, and I want you to remember, that there are a lot of marker words in these messages. There are words like table that hints to a database. There's words like undefined and null pointer that could hint at middleware or backend. And there are the close to natural language error messages and warnings that usually come from the front end. And names hold meaning. That's true outside of software, and it's also very true when it comes to messages. So learning a bit about the different part of your ecosystem, your application, more than just the little part that your team works on, will help you find a lot of these problems. So SMTP, for example, anything that says SMTP is probably related to a mail server because that's a mail server. Errors that start with Aura is typically an Oracle database error. If it says Java dot, it's probably a Java error. And there are more of these. There are SQL, there are Python and Go, and all of these different things that you can often find in the unhandled error messages, I should say. So names hold meaning, and learning about them will make you a better tester. And there's also a type for everyone. So I'm going to be generalizing heavily in this session, but it's to give you an idea of where to start. So as an example, you have three very common errors or error types. We have divide by zero, that likely hints to a value is missing somewhere, because we rarely want to divide something with zero. So it typically means that somewhere a value was not propagated to the right place in the code. We have overflow errors that mean that you are trying to put something that is too big into a bucket. So a very common problem is that you use an integer data type that is a quite small data type, and then you forget that there's a possibility that you might get zillions of orders, and suddenly that integer isn't big enough. And then the bucket that you're trying to put stuff into will overflow, and you will get an overflow error. Unique constraints is also something that's very good to know about, which usually means that you are trying to put the same thing into the database twice. So it could be you're trying to create a user with the same personal number or the same username, or whatever you have said in your application, that there can only be one of these. So divide by zero, overflow, and unique constraints are a group of error messages that are extremely common, and I would encourage you to read up more about them. And then we have errors that can be grouped by the fact that they are likely related to someone running through a list of something and either trying to start before the list starts or access something that doesn't exist in the list. So we have index out of bounds, index, and then usually a number does not exist. index out of range exception. These are all examples of when we try to go through a list or an array from start to end, but we somehow messed up. So we're either on -1 or we're on trying to access the row after the one we're trying to access. And these are very interesting, and I've been talking about these in other talks as well, because they are very related to the fact that programming is quite hard, because in a lot of programming languages, we start counting at 0, but humans rarely do that. We start counting at 1. So if I ask you to count to 7, you would likely start to 1, while the computer would probably start at 0. It's also extremely easy to mess up when you try to compare two different values, either by comparing them in the wrong way or by messing up the larger than, smaller than, larger than or equal to, smaller than or equal to. It's very easy to make mistakes here, which is why loops are my favorite things to test, because you find so many problems here that are just connected to human language and computer language being very different. And then we have a group of problems that are related to the fact that you don't have the correct access right for some reason. So something is wrong with your credentials or your users, and they can look like this. We have access denied, we have forbidden 403, or the very specific, you don't have permission to access this server. This could point at something that's easy for you to fix. It could be you're not logged in. It could be you have multiple browsers open and you're logged in as different users and you're trying to access, say you're logged in as user A and user B, and you're trying to access the other user's document in the wrong session. It could be that it's just not set up correctly. Maybe another tester went in and changed the access right of your test user. Or you're trying to do something that you're actually not supposed to be allowed to do. So an example would be trying to access someone's Google Docs if they haven't shared it with you properly. But the interesting part of this could also be something extremely technical, like your session or your cookie is not set up correctly, or your browser has a setting that makes it impossible to access whatever you're trying to do, or my favorite, the cache of your browser is corrupted. All of these things. So, but what they have in common is that they are connected to your access rights in some way. And then we can also look at them in a different type of grouping. So here are 3 examples of JavaScript errors. So front-end or front-end adjacent nowadays. We have unexpected token, which means a piece of code was encountered that was not expected. So generalizing heavily, this is typically that a programmer did a typo somewhere, or they did not anticipate a particular value being possible to occur in a place. We have reference error or type error undefined. And these typically mean that a variable has not been defined yet. So typically, programmers tend to think very orderly or sequential. So first, the user will do A, and then B, and then C, and that's the way we write our code. But then sometimes things happen that we didn't anticipate. So we change something, and suddenly you can access a piece of code too soon. Or you you anticipate something taking a certain amount of time, and suddenly the computer science just evolves, so the browsers become 10 times as fast. So undefined typically means that something happened in an order that it wasn't supposed to happen. If we look at some backend examples, we have the same error as before. The object reference not set to an instance of an object. That's the same problem as in the front-end examples, but the backend version of it. And we also have IO exceptions that I love, which means that something went wrong when we were trying to read or access something like files or directories, or we got the wrong type of data. We're trying to write to a file that doesn't exist. So IO is typically connected to reading and writing something, printer or a file or something. And then we have the amazing big 400 bad requests. I could also say malformed request, which is kind of like a client-side generic error, meaning, okay, I went through all of the different ways this could be wrong. I can't classify it, so let's just slam it into 400 bad requests. It could be something generic like, oops, the page isn't working. If the problem continues, contact the site owner. Doesn't tell you anything about what went wrong. It could also be something extremely specific, like you entered the wrong URL or the DNS lookup failed. The file is too large, and then hopefully you would get that in your error message, because 400 has a bunch of children error messages that you can send. It could also be something like this, where you get a lot of information. You get that the data being sent is not in the right format. So 1, 2, 3, 4, 5, 6 is not a valid phone number. All of these different ways are still the same error messages, 400 bad requests. Typically, they mean we are trying to send something from the client, the code being run on the user side, and the server, the code that's being run outside of the user's computer. The server will not be able to handle that request. There's a zillion amazing examples and variants to 400 bad requests. And I have a very special place in my heart for databases, so you're going to get some more database examples. Their database errors are interesting because they can be grouped into 3 very clear areas. We have errors that are related to the data. You are trying to put something into the database, but it breaks the rule. So we have unique constraints that I mentioned before. We have value out of range, which means you're trying to put a too big or too small number into something, for example. And we have, of course, more, but there are a number of database errors that are connected to the data you're trying to put into it. And then we have errors that are related to the mechanics or the structure of the database. So database views, structure of tables and the relations between them, fields that are not configured to let you do whatever it is you're trying to do. Or it could be the database functionality. Say you're migrating from a SQL server to an Oracle server, and they should behave similarly, but they have slightly different functionality, and suddenly something you are used to being able to do won't work. So we have things like object not found, package body could not be compiled, cannot modify more than one base table through a joint view, all examples of errors that are related to how the database is set up. And then we have the horrors, the errors that are related to the state of the database. Deadlocks, we have transactions that are out of sync, or if something really bad happens, the database is starting up or shutting down. For some reason, things are not in the state they should be to do what it is you're trying to do. Why I say these are horrors is because they can be incredibly hard to find when testing, because they will not show up consistently. They will not show up every time you do something. They will show up in a very specific set of circumstances or under a certain load. So that was a lot of information. Let's get back to images for a while. Let's look at an example. This is an example that I found in the wild while I was researching for this. It is a sign-in page, and you get an error message saying request failed with status code 400. This is probably a backend or API error, which I guess because it has a slightly vague message and the status code 400 that I mentioned before. If this was a front end or a validation, this was caught in the front end, the error message would probably look more like this. It's the natural friendly language. It gives you more information of what you need to do, and it's easier to fix this problem as a user. It says invalid email or password. Please check and try again. And if it was a database validation, it would probably look something like this. Aura 0001, no data found. So the database couldn't find the combination of email and password that you sent in. These were pretty straightforward examples, but sometimes you need to really look deep and use information and detective skills. So, for example, I think I showed this in a different part one or part two. This is hopefully an error messages you don't see much, but they still exist out in the wild. Nowadays, these are typically replaced with one of those, oops, something went wrong instead. But this is likely a database error, and I guess that because of the marker words in the message. So you have words like column and SQL and table and such. So my guess, I don't know, is that this is a database error. But it looks very similar to this, to the untrained eye, if you haven't trained yourself to look for this information. This is probably a backend error, which I guess, because it has a different, slightly at least, different language, and it uses words like server encountered, null point error, and there is no reference to a database anywhere in this message. So sometimes it can be very clear, and sometimes you have to look a bit deeper. But summing up these 20 minutes, learning about tech, even though you're not a programmer or a database architect or anything, learning about tech is a great way to do better testing. And it only requires you to spend a little more time on learning something every week. And the messages we receive include so many clues once you train yourself to look for them. And learning about those traits, the differences, the characteristics will help us immensely in exploring and uncover risk. So summing 20 times 3 minutes into one slide would be what looks like gibberish is really a cipher. You just need to learn how to crack the code. Thank you so much for having me, PractiTest. Thank you for listening. I'm so glad I got to do this.
Yeah, thank you so much for being pioneer and for all the information. Let's give it one more minute for people to ask questions if they have any.
Maybe they fainted from all of that.
I'm sure they didn't. Okay. What is the biggest problem you see when it comes to messages and validations?
That people think it's easy or straightforward. It is, I mean, it's really hard to get people to understand why it's complex and like the trade-offs you have to do all the time. Because I think I got a question in another one, like, why can't you just translate them and send them along? And the complexity that would add to the code is just, the cost of that is just so immense. So from my perspective, that's the biggest problem, that you can't make it perfectly and there are always trade-offs.
It's the jugglings between them. How do I make my team listen to my concerns? They don't see me as technical enough, sorry.
Oh, different talk perhaps. On the softer side, build relationships, build trust, show by actions that you're reliable, you don't cry wolf. It's bug advocacy. There's a BBST course on bug advocacy that is great. Learning about how to communicate importance, basically. But on the other side, also learning more about tech without having to be learning how to code. You can learn about your ecosystem. You can learn
about the company, about your colleagues.
Request. You can learn about many things. And showing that you're trying and that you're understanding those things will also help with like your street cred.
And make your bugs very professional.
Yes. Or don't write them as bug, go talk to the developer instead. Show them what you did.
Present them as you want other people to be presented to. Yeah. Anyone else? Okay. I think that's that, Lena. Thank you so much again. Thank you for joining us. Thank you for all your helpful thoughts and ideas. And we'll be sharing this on our YouTube channel, on our website. Check it out. Check the previous two if you haven't yet. Bye. Have a great rest of the week.
Bye-bye.